Hello everyone, welcome to the channel of Algocamp. So now on this particular channel, we are actually releasing a series on data structures and algorithms where we are going to talk about some of the most important data structures and algorithmic topics which are extremely important for your upcoming software engineering interviews. Apart from that, these are some of the I would say topics that are very helpful in your day-to-day engineering job as well. We have already released a couple of series around searching, right? And we got a really good response on that. And from here, we are going to put really some awesome content around DSA. In most of these lectures, we will try to ensure that we focus on the intuition building aspect of the things, that how you are able to think about something, what are some of the things that people actually neglect but are going to clear some of the really important fundamentals. We are going to see coding implementation, but trust me, my focus is not going to be on the language delivery aspect of the things, that okay, you have to code this in C++ or Java. A lot of problems we have coded in multiple languages. Maybe some of the problems will be in C++, some will be only in JavaScript. I believe if you are somebody who is preparing for an interview, language in 2025 should not be a constraint, because most of the people can actually use ChatGPT to do language conversions. So my motive here is to make sure that you understand the concept in depth. You actually see how exactly somebody might have thought about the problem when they were carving out the problem, what can be some initial thought process, how you can actually drive yourself towards the solution. I believe these are going to be some really important videos that will be really helpful for your upcoming career. So do let us know what is your feedback. We are going to release a lot of more topics. Do let us know what all topics you want to have first, right? And the feedback is going to be important. Also, in case you are actually thinking to level up, you want to learn things with respect to low-level design, high-level design, overall system design for interviews, or you are somebody who wants to do project development in Spring Boot, you want to learn advanced Spring Boot concepts, or let's say advanced Node.js concepts, then we have a lot of courses, live courses running on algocamp.io. So you can check out the website courses.algocamp.io/learn, and there are a lot of courses that are actually listed. A lot of great discounts are actually going on all the courses as well. Do check them out. For each and every single course, we are going to add you to a dedicated Discord community where you can get your doubts resolved as well. All of the courses, we have made sure that we talk about things from the very beginner to the very advanced level that is going to help you level up in your career as a software engineer. So that being said, let's start the video without any further delay. Now there is a very interesting question that people might ask you, that why we only divide array into two parts and not three in merge sort. Like, what is the harm of, instead of doing two parts, why not do three parts? Because in two parts you are getting a factor of log n base 2. In three parts you'll get a factor of log n base 3. Log n, and we know log n base 3 is lesser than log n base 2. So why not divide the array into three parts instead of two parts? So the reason lies in the number of comparisons, because if you will start dividing your array into three parts, so from n you will go to n by 3, so you'll get three instances of n by 3. You will sort this half, this, like this 1 by 3 part, this 1 by 3 part, this 1 by 3 part, and then you have to merge three arrays of size n by 3. Okay, so technically T of n will be equal to what? T of n by 3 plus T of n by 3 plus T of n by 3. So you have to merge three arrays of n by 3. So what is T of n? It is the number of operations for doing merge sort on size n. What will be the number of operation? Number of operation will be equal to number of operation for sorting the first 1 by 3 part plus number of operation for sorting for second n by 3 part, number of operations for the third n by 3 part, plus f of n. What is f of n? Number of operations to merge these arrays, right? Now when you were dividing in two parts. So before we start this particular video, I wanted to actually talk about a very small thing. So this video is going to actually help you understand a real system design interview scenario. We are going to try to mimic a 45 to 60 minute kind of like a round where we are going to solve a problem very similar to how you will solve a similar system design problem in this short time frame. Now, of course, when you work as a software engineer in a company, you have relatively larger amount of time and you can do a lot of more deep dives in even very small level features. But in an interview, the temperament is different, the approach is different, and a similar scenario is actually explained in this particular video. So do consume the content based on that. Also, if you want to see more deep dives and want to understand these topics in a much more deeper level concepts, then do check out the link in the description section below for our System Design 2.0 cohort, where we have talked about a lot more concepts in a lot more detail, which will make you definitely a better software engineer. So let's just start the video. You had only n by 2 and n by 2, and we know the complexity to merge two sorted arrays. It's order of n plus m, so n plus m is n by 2 plus n by 2 n. Now what will happen when you are doing merging of three sorted arrays? So how will you merge three sorted arrays? Let's say all of them are of size n by 3. Okay. A simple approach can be first merge these two and then whatever is the result, merge these two. Can I say that? What I'm trying to say is, if you want to merge three sorted arrays, merge the first two, you will get something, and then merge the new result with the last one. Okay. So let's see how many operations we need. To merge two arrays of size n by 3, how much operations will be there? N by 3 plus n by 3, that is, right, n by 3 plus n by 3, to merge these two arrays and get a new array of size 2n by 3. And then this 2n by 3 plus n by 3. So more operations plus 2n by 3 plus n by 3. And then only you will get a final array of size n. So what is this? N by 3 plus n by 3 plus 2n by 3 plus n by 3. Can I say this is 5n by 3? So if you are dividing your array into three parts of n by 3, the total number of comparisons you are doing 5n by 3. Whereas when you are dividing your array into two parts, n by 2 and n by 2, you are doing n comparisons. And can I say 5n by 3 is greater than n? 5n by 3 is greater than n. So at last you will be having this factor of 5 by 3, which will lead to more comparisons. And although you have log n factor to base 3, but this 5 by 3 will be way huge. Like if you do divide 5 with 3, it's almost a factor of 1.66. That is going to explode, right? Let me explain how we got 5n by 3. You have n by 3, n by 3, n by 3. Okay. You will first merge these two. So how many operations is required to merge two arrays of size n by 3? Can I say n by 3 plus n by 3, because we know it's order of n plus m, right? So n by 3 plus n by 3 to merge the first two and get a new result. Still the work is not done. This new result and this n by 3. So this is of size 2n by 3. This is of size n by 3. Length is 2n by 3, n by 3. So plus n plus m more. So n by 3 plus n by 3 plus 2n by 3 plus n by 3 is 5n by 3. And 5n by 3 is more comparisons than n. That's why we don't divide our array into three parts and we divide our array into two parts, right? Because at last, although the factor will be n log of n base 3, like in big O, that it doesn't even matter, base doesn't even matter, because in big O, log bases we avoid because log bases are interconvertible by constant multiplications. But if you will see exact number of comparisons on each level, then and on each level, the exact number of comparisons will increase by a factor of 5 by 3. On each level, the comparisons were initially n. Now there are 5n by 3. So there is increase in the number of comparison per level. So you can see like overall combination 5 by 3 log n times is going to be huge. That's the reason why we don't divide it in three parts. Some people might ask you. Here you can see the comparisons are increasing by a factor of 5 by 3. It's not like previously there were n comparison and now you have 5n by 3. It's like 5n by 3 per level. So the overall factor increases by 5 by 3, right? So 5 by 3 n comparisons per level are increasing.